What's up? Welcome to Backend Stuff. I'm Jacob Blitzo, here to help you build tech for the future. Think about scalability, reliability, and cost. If you want to learn how to build scalable production-ready APIs, hit that subscribe button now. This is episode 10 in Elixir Basics. Today, we are diving into anonymous functions. What are anonymous functions, you ask? Well, they allow us to store and pass executable code around as if it was an integer or a string. They are delimited by the keywords fn and end. They can also be created dynamically. Functions in Elixir are treated as first-class citizens. What that means for us is both named and anonymous functions can be assigned to variables. Both named and anonymous functions can be passed around like data as arguments and return values. Let's go ahead and get started. Let's just do a command space and open up our terminal. Let me make this big enough for you. And let's go ahead and cd to our desktop. So cd desktop, enter. And let's make a new project with mix new, and we'll call this project anonymous. So anonymous. And then let's go ahead and cd into the anonymous directory. And we can go ahead and jump right into our Elixir shell. So let's do an IEX space dash capital S space mix. And now we're in the shell. Anonymous functions are commonly used throughout Elixir on their own as return values and as arguments in higher order functions like the enum.map function that we've used in the past. So funny enough, you've already used an anonymous function. So if we did a quick example like enum.map, open parentheses, opening square bracket, and we're just going to pass in a short list just with integers 1, 2, 3, and then closing square brackets. Now comma, so they're delimited by fn. So fn, and then we do our anonymous expression, which would be whatever value we're mapping through in the list, we're going to assign to n. And then we're going to enter our function with that argument, and we're going to just add 1. So n plus 1, and then we want to end the anonymous expression with the end keyword. And then we want to just do a closing parentheses. So you've seen this before in past videos. Between fn and end, that is an anonymous function. So if we hit enter, we're going to see that our list of 1, 2, 3 all got 1 added to each value. So now we have 2, 3, 4. Let's define our first anonymous function. We will have it take 2 arguments and add them together. So we're going to just make a variable called add, and we're going to set that equal to our first anonymous function that we're creating. So just do an fn space, and then we're going to do a comma b. These are the 2 arguments that are coming into our function. And then we do a dash greater than to enter our function executable code, and we're just adding them together. So a plus b, and then hit end. And now if we hit enter, we have that function added to a variable called add. How do we use our anonymous function now? We can just do this. We can do add. Now you need the dot, and then you always need a dot to access the anonymous function when it's added to a variable. And then we just do opening parentheses, and we pass in the 2 arguments we want to add together. So let's say we want to just add 1, and 2, close those parentheses, hit enter, and there you go. You see 3. So that's pretty cool. We added a function to a variable. We can also check with a kernel function to see if a variable is a function. So we can just do this. We can do is underscore function. Helps to spell. So is underscore function, open parentheses, and let's put in our add variable, close parentheses, and hit enter. And look at that, we get a true. So our add variable is a function. We can even check to see if a variable is a function that takes 2 arguments. So we can do the same thing. So is underscore function, open parentheses, add, comma, and now if we put in 2, it means we're verifying that it accepts 2 arguments, and then close parentheses, and we get a true. And now just to show you that we would get false, if we wanted to know if it only takes 1 argument instead of 2, now we get a false. So our variable is set to an anonymous function that accepts 2 arguments. And you can check it with the is_function. Anonymous functions can also be created with the capture operator. This is called capture shorthand. The initial capture operator declares the start of the capture expression. So we can do the shorthand version of the add function that we just did like this. We can do add equals, and then the capture operator space, and then we are going to do the capture operator again with a 1 space, and then plus space capture operator 2. Since our add function takes 2 arguments, it automatically will assign them to 1 and 2 in order of what we passed them into. And this would go on and on to the position of the arguments for the anonymous function. So if we had 3 arguments, we would do capture operator 3. So now just to show you that this works the same way, we're going to hit enter. And now if we do add dot, open parentheses, and we pass in 2, 3, close parentheses, we're going to get 5 back. So the shorthand is pretty cool with the capture operator. Another cool thing that we can do, you can also use like existing functions with the capture operator. So instead of doing something like this, we can just do, so existing is going to be our variable equals fn a comma b are our parameters dash greater than. We just want to know if a is less than or equal to b end. Okay, so if we did existing dot opening parentheses 2, 3. So obviously 2 is less than 3, so we get true. The capture shorthand expression of this, we could do the same thing. So we can do existing equals, and then it's even easier than the adding one. We do the capture operator, and then we just do the function. So greater than or equal to with the arity afterwards. So you know how functions have the arity where it's like we take 2 arguments, just like that. Okay, so we hit enter, and now we can do existing dot opening parentheses, and we can do 4, 3, close parentheses, and we're going to get false. So shorthand is pretty cool. Saves you a lot of typing. So another thing to keep in mind, anonymous functions in Elixir are closures. They can access variables that are in scope when the function is defined. Variables assigned inside of an anonymous function are not accessible outside of it. So remember when we talked about variable scoping in the control flow structures video? It's the same concept here. So I'm going to just write out a quick example. So if we do y equals 4, and then we do scope as our variable equals fn, and then we can do dash greater than. And I'm just going to hit enter so you can see multiple lines on this function. And then if inside of this variable or anonymous function, I'm going to just do x equals 3 and then hit enter again, and then x times y, enter, and then I'm going to end this anonymous function. So I hit end, and now scope holds that function. So if I call scope dot opening closing parentheses, we're going to get 12 back. So it multiplied y, which was outside of the function, but within its scope, right? And then it multiplied it by 3, which is 12. So now we're outside of the function. If I typed x here, we get a compile error because x variable was inside the anonymous function. We don't have access to it. So it does not exist when we're outside of the anonymous function. And that just falls into the variable scoping that we talked about in the past. All right, let's go ahead and open up our project now. So go ahead and do a file, open folder, find our desktop, and open the anonymous directory. And I'll drag that over. And now let's go ahead and expand the lib directory and double click on anonymous.ex. And as always, let's delete our hello world because we don't need it. We are writing our own code. Let's make our getEquipmentList function that we've used in the past, just so we can easily have access to a list for this guy. So we're going to do def get underscore equipment underscore list, opening, closing parentheses, do, and end to close off the function. Opening square bracket, and then we're just going to have our atoms in here. So colon space underscore helmet, comma, colon space underscore suit, comma, colon snacks, comma, colon grappling hook, comma, colon probe, and then closing square bracket, and our list function is ready to go. Let's write a function now using anonymous expressions to get the first item out of our equipment list. All right, so let's make a function. So def, whoa, what's going on? Def get underscore first underscore item, and it will take an argument of a list, closing parentheses, do, and then the end. We can do pattern matching with arguments, and that works for anonymous functions as well. So we can do something like first equals fn, and then we can pass in our head and tail. So opening square bracket, head, the pipe key, space underscore the rest, so the tail, closing square bracket. And I just did the underscore rest because we're not going to be using that variable, and I don't want the IDE to yell at us. And then do a dash greater than, and then let's just return the head end. So we just set an anonymous function that returns the head of a list, and we set that function to a variable. And so now we can just do first dot opening parentheses and pass in our list, closing parentheses. Let's save it, and let's go ahead and go to our Elixir shell. Let's do a recompile. And now if we call our anonymous dot get first item. Oh, you know what we have to do though? We have to do our get, we have to set our variable. So list equals anonymous dot get equipment list. All right, so we have a variable list set now. And now let's go ahead and call the function we just wrote. So anonymous get first item, and then opening parentheses, pass in our list, closing parentheses, hit enter, and we should get space helmet back. Look at that. So we got space helmet back. All right, let's do something a little harder. I mean, these are just real basic examples to show you how anonymous functions work. And it's pretty cool that you can pass them around as a variable, right? All right, so let's use it as an argument now in an enum map. So let's make a function called def atom to string. So I want to take all of our atoms and I want to convert them to strings. I want to uppercase all the letters and replace the dash, the underscore with a space. I want it more readable, okay? So atom to, and then we're going to pass in an argument list and then do, and then let's go ahead and call a variable convert equals, and now let's do our anonymous expression. So fn x dash greater than, and we want to convert an atom to a string first. So to underscore string, we pass in x, close that parentheses, and then you know what we're gonna do just to make this more readable? I'm gonna put, whoops, to string underneath here, and then we're going to just, let's pipe, and then I want to uppercase that once it's a string. So string dot uppercase. Awesome. And then we want to do a string dot replace. And I know we've done all these before. That's why I'm kind of going through quickly. So we want to replace the underscore, comma, and we just want it to be a space. All right. And then let's end our anonymous function. And then down below, if you remember in the shell, we wrote an anonymous function in a map, right? So we did enum.map. We had our list, and then we had our anonymous function here. But since we already have an anonymous function set to a variable, all we have to do is put our variable convert right here. Let's save it and go back to our shell. And if we do a recompile, if we call our anonymous atom to string function and pass our list in, hit enter, we should get all caps, no underscores, and it should all be, look at that. Everything is converted and set up the way we want it. We no longer have atoms, we have strings, all uppercase, no more underscores. So that's pretty cool. We wrote a function that was used over and over in an enum map. So that was us using an anonymous function as an argument. So let's finish up today with combining pattern matching and passing in an anonymous function as an argument. If you remember from our pattern matching video, let's go write the same code, the equipment detail functions that we wrote. So let's go ahead, go back into VS Code, our anonymous.ex file, and right underneath our get equipment list, let's write out our def. Remember our item underscore details that returned a tuple to us? And we did pattern matching. So when it was the space helmet, we returned exactly like how much it weighed, the type that kilograms, the type that the weight was recorded in, and then the quantity. So remember all these? We're going to go ahead and just write them all out again. So def item details, we got a spacesuit, closing parentheses do, and this one weighed 16 kilograms and we got a quantity of 1. Whoops, my cursor is jumping all over the place. All right, so def item details, and then we got our snacks, and that was, let's see, 1 kilogram, we got 16 of those, and then we had def item, our grappling hook, and that weighed 4 kilograms, and we had 1 of those. All right, and then lastly, we had our item details, we got our probe. Okay, do, and then for this one, I'm going to return 2, and instead of kilograms, I want to just have pound, and then quantity of 1. And you'll see why I want it to be a pound in a second. And then let's go ahead and actually right underneath these, we can write our new function. So now let's use the power of passing in an anonymous function as an argument in an enum.map again, but this time our anonymous expression will use pattern matching and a case statement for converting any item that is in kilograms to pounds. So I want to do def get weight in pounds, and it's going to take an argument. It's going to take our list. So our atom list, okay? And then do. All right, now let's write our anonymous expression. So we're gonna call the variable get pounds equals, and then let's start our anonymous expression with fn, and then we're going to take the item that we're on. So whatever item is this, so it could be just the grappling hook, right? And then dash greater than, and then we're going to use the power of pattern matching here. So we're going to set a tuple. We have weight, type, and quantity. We're not going to use our quantity variable, so put an underscore in front of it, but we still want it there. And then this is going to equal item details, okay? And we're going to pass in our item. So we're calling our item details function and we're passing in an atom. And then it's going to return the exact tuple. So if it was a grappling hook, it would return 4 kilograms, quantity of 1, okay? And then underneath this, still inside our anonymous function, we're going to write a case a case structure, and we're going to check the type. All right, and then down here, if the type is kilograms and we're comparing it to an atom, we want to take the weight, so WT times 2.2, and then it's going to return the converted kilograms. It's going to return the pounds of the item. And then for everything else, we're just going to do an underscore dash greater than. For everything else, since we only have kilograms and pounds in the list, if it's not a kilogram, we're assuming it's a pound, and then we can just return weight, and we don't have to do anything else to it. All right, and then, whoops, sorry guys, scrolling all over the place. We're going to go underneath our anonymous function where that ends, and we're just going to do our enum.map. Now we're going to map through the list of atoms, comma, and then as we're mapping through, we're going to pass each item into our anonymous function that is now called get pounds, close parentheses. So every time we map through the list, it's going to pass one singular item into our anonymous function. And that item, we're going to grab the details in this anonymous function. And then if it's a kilogram, we're going to convert it to pounds. And if it's pounds, we're just going to return the weight. So we should get a list of just weight back of each equipment, of each piece of equipment, but in pounds, not kilograms. So if we save this and go back to our terminal, let's recompile and then do anonymous dot get underscore weight pounds. And then we're going to pass in our list. And now when we hit enter, we should get a list back of weight. And look at that. We have a list back of weight. We got 6.6 pounds, 35.2 pounds, 2.2 pounds, 8.8 pounds. And then our last value is just 2 pounds. And our probe, if you remember, let's go back to our code, was 2 pounds. So we didn't convert it. We just passed the value back. So anonymous functions can be pretty cool. With that being said, it's challenge time. I want you guys to write documentation for all these functions. And I want you to write tests for all of our functions as well. I don't have a code challenge for this one, but I want you to take the time to play around and write some of your own anonymous functions. To be honest, you're not going to use them very often in production apps because they make things less clear and it's much easier to document named functions, but they do have their uses and you should be familiar with how they work. As always, if you need help or want to check out the solutions, check out that GitHub link in the description below. And if you have any more questions or just want to hang out and chat, join my Discord server, Backend Stuff. That link is in the description as well. If you want to learn how to build scalable, production-ready APIs, hit that subscribe button now. See you guys next time.